Hello, everyone. Let's talk about how to create a polynomial given some conditions. Now, notice our goal here is to write a polynomial in factored form, but we don't want to use complex linear factors. That means we should not see any i's in our factored form. Now, let's talk about what each condition tells us. So if I have the requirement that the degree of my polynomial must be 5, this means, by the fundamental theorem of algebra, that there are 5 zeros counting multiplicity. So we don't know yet if one of the zeros is repeated. Or squared or cubed or something. We just know we need 5 of them. Now, the zeros of P and X include x equals 1, x equals negative 6i, and x equals 1 minus I. So I have 3 zeros. Let's go ahead and write their companion factors. We have x minus 1, x minus negative 6i, and x minus 1 minus I. I'm going to go ahead and simplify that a little bit and rewrite it as x minus 1 times x plus 6i times x minus 1 plus I. Now, the problem is since this is degree 5, we're missing 2 factors. And the question is, what are those 2 factors? So at first glance, it seems like they can be whatever we want. However, there's this condition that says we do not want complex linear factors. That means we need to somehow get rid of the i's in here. And how do we do that? With conjugate pairs. In other words, we know that if x equals negative 6i is a 0, if we want to have no i's in our final polynomial, if we don't want non-real linear factors, x equals positive 6i must be a 0. Similarly, if x minus 1i is a 0, we must have 1 plus I. So that gives us 2 factors of x minus 6i and x minus 1 minus I. I can simplify that second factor to give us x minus 1 plus I. So we're really close to being done. We just want to simplify this to get rid of the complex linear factors. We're going to do that by looking at our conjugate pairs together, because that's why we have them. You could multiply this out one at a time, but it's a little bit easier if we just use our conjugate pairs. It's okay to leave it in factored form. We just want to combine the factors that are nice to combine. So let's start out by combining x plus 6i times x minus 6i. Now there's a couple ways we can do this. We can go ahead and just multiply it out. I like to notice, though, that we have a plus 6i and a minus 6i. You may remember that that means this equals x squared minus 6i all squared, or in other words, x squared minus 36i squared. Now the question is, what happens to the I here? Isn't it supposed to disappear? Well, remember that I is the square root of negative 1. So I squared is negative 1. So this turns into x squared minus 36 times negative 1, which is just x squared plus 36. So now if I'm building my final answer, This means that my final answer is going to have an x minus 1 and an x squared plus 36. So now we need to do something similar for the x minus 1 plus I. Oops, I apologize. I realize I made a little error here. That should be a x minus 1 plus I, and this should be a minus here. Anyway, I need to combine those two factors. I can think of it similarly as a difference of squares, though it can get a little nasty. So what we're going to do instead is we're going to just straight up multiply it. We're going to multiply x minus 1 plus I times x minus 1 minus I. Now, I like to think of these in an area model to help remind me to completely distribute my multiplication. So here I have x minus 1 plus I, x minus 1 minus I, and this x is going to get multiplied by all three of these things. So I end up with an x squared minus x minus ix. I end up with a negative x in my second row, multiplying the negative 1 by each piece of the other factor. Let's see, a negative x, I get a positive 1, I get a positive I end up with an ix in the lower left-hand corner, a minus I, and a negative I squared. Now, the first thing I notice is some nice things happen. First, I plus negative I is just 0. And ix plus negative ix is also 0. Those subtract each other out. So in the end, I end up with x squared minus 2x plus 1 minus I squared. But remember, we talked about before that I squared is negative 1. So I end up with x squared minus 2x plus 1 minus negative 1, which gives me x squared minus 2x plus 2. And I can go ahead and add that to my answer. X squared plus 2x plus 2. So let's check to make sure we've met all the conditions in the original problem. We were told to write it in factored form, which we did. We have no complex linear factors, which means there's no i's in here. We know that the degree of p is 5, and I can check that because if I were to multiply this out, I'd have to do an x times an x squared times an x squared, and that's x to the 5th. We have zeros of 1, negative 6i, and 1 minus I. But as x goes to negative infinity, p of x goes to infinity. We know that our general 5th degree polynomial is going to look something like this. It may not look exactly like it, but in this case, the way it's written, it looks something like this. And you'll notice in this case, as x goes to negative infinity, p of x goes to negative infinity. We need to do something to change that. Because right now, as I go to the left, as I go to negative infinity, I'm going down, whereas the problem asks me to make it go up. Well, how do I do that? Well, I don't want to change the zeros, so all I'm going to do is reflect it over the x-axis with a negative in front. And that makes it look something like this. And that fits the condition we're looking for, whereas I go to the left, it's going to positive infinity. And that would be our final answer. All right, I hope that was helpful.